There are uncountable amounts of planets in the universe outside of our own solar system. These planets are called exoplanets, the prefix exo meaning outside of our own solar system. Studying these planets is exciting because they teach us about the formation of our own solar system and allow us to find planets that could possibly sustain life. Exoplanets are actually really hard to detect because of their relatively small size. In fact, only around 6,300 have been confirmed. There are two main ways to detect exoplanets. There are several more ways, but these two have found around 6,000 of the 6,300 exoplanets. First method I want to talk about is a transit method. A transit is when a planet passes between a star and the observer. The transit method of detecting exoplanets takes the brightness of a star and looks for when the brightness dips. When it dips, it is because of the transit of a planet passing through. From this, you can also tell the size, atmosphere, and time it takes for each orbit of the exoplanet. The second method is the radical velocity method. We can detect an exoplanet by seeing if a star is wobbling, meaning it is moving around a common plane of mass between a planet and a star. Since a planet has a lot less mass than the star, the planet's gravity won't influence the star as much. However, if the planet is close enough and has enough mass, the star moves, wobbles, enough where we can detect it by seeing the shift in wavelength of the light as it is observed on Earth. To see if a star is wobbling, we will collect measurements of the star's wavelength, varying between being redshifted, meaning it is moving away from us, and blue shifted, meaning it is coming towards our direction. This blue and redshift also tells us important things about the exoplanet, like the mass, orbital period, and distance from the star. As exoplanets move in front of their star, some of the light is absorbed by the gas in their atmosphere. Every element and molecule absorbs light at very specific wavelengths. Because of this absorption, when a planet is in transit, you can get a spectra of the planet's atmosphere, with dips at certain wavelengths. And with these dips, you can find out the chemical composition of the planet's atmosphere. By seeing the composition of different planets' atmospheres, we can look for planets that could possibly sustain life. By studying exoplanets, scientists hope to understand the formation of our own solar system better. By comparing the planets in our own solar system with the planets in other solar systems, scientists plan on creating a better understanding for the reasons for the vast diversity in exoplanets, and discover why some are so different from our own planets. Planets are fundamental to understanding the origins of our solar system, but even more crucially, they give us a possible answer to one of humanity's greatest questions. Are we alone in the universe? I really enjoyed making this video about exoplanets. If you'd like to see me making a video discussing the different types, please let me know in the comments. If you enjoyed the video, please like and subscribe, and I'll see you in the next one.